Alright, this is assignment 2. Let's do some more examples. First example is, suppose W1 and W2 are two-dimensional subspaces of R3. Show that their intersection is not equal to the zero element. Now, since it's not given to us that W1 and W2 are distinct here, right? But these are having the dimension equal to 2. And dimension of R3 is 3. So we should take the dimension of W1 plus W2. We can take this dimension to be equal to 2, starting from 2, right? Okay. Now, since the sum of the subspaces is a subset of R3, yes, and dimension of R3 is 3, very right. Okay, so therefore the dimension of their summation, therefore the dimension of their sum is equal to strictly less than 2 or greater than 2 or equal to 2. What can we take? It's not given to us that these subspaces are distinct. See, if it is given to us that the subspaces are distinct, having the dimension say n, then we must take the dimension of their sum to be strictly greater than n, right? But here it's not given to us that these subspaces are distinct. So we can take the dimension of their sum to be equal to their dimension. That is, we can take this dimension to be equal to 2, or the dimension of their sum is equal to the dimension of the given vector space, which is 3. Okay, and yes, of course, the dimension of this sum cannot be greater than the dimension of the vector space, right? Okay, now since the dimension of their sum is equal to, we know the formula that it is dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Right? We have to show that their intersection is non-zero. For that, this intersection must have some dimension, which means, right? Okay, so we have to just find out the dimension of W1 intersection W2. If this dimension is 0, then we cannot get the result. So this dimension should be non-zero. So taking this intersection to the other side, and this is equal to dimension W1 plus dimension W2 minus dimension of their sum. So dimension of W1 and W2 is 2. So this is 2 plus 2 minus the dimension of their sum. So this is equal to 4 minus dimension of their sum. Okay, now this dimension is, if dimension of their sum is equal to 2, put here 2, you get 4 minus 2 as 2. So the dimension of intersection is 2 if the dimension of their sum is 2. And this is equal to, if I put 3 over here, I get 4 minus 3, 1. So we get 1 if dimension of the sum of the subspaces is 3. So which means the dimension of their intersection is either 2 or 1. That means the dimension of their intersection is not equal to the 0 element, right? Okay, the second example is, suppose W1 and W2 are subspaces of V and that dimension W1 is 4, dimension W2 is 5 and dimension V is 7. Find the possible dimension of their intersection. Now here dimension of first subspace is 4 and the other one is having 5. Not same, right? Different one. Okay. Now since W1 plus W2, the sum of the subspaces is a subset of V and the dimension of V is given to be 7. So what can you guess about the dimension of their sum? Can the dimension is equal to 4? Can that dimension is equal to 5? Yes. Yes, it can be equal to 5 but not equal to 4 because we are taking the dimension of the sum of the subspaces and one of them subspaces is having dimension more than the other. So we have to take the dimension, we can take the dimension 5 but not 4 because we are taking the sum, right? We are taking the dimension of the sum of the subspaces. So we can take this dimension as 5 but not 4 and or 6 or the dimension of the vector space which is 7. That's it. Now since the dimension of W1 plus W2 is equal to, yes, what is the formula? Dimension W1 plus dimension W2 minus dimension of intersection. So, sorry, this is equal to dimension of W1 is 4 and dimension of W2 is 5 and then dimension of their intersection. So 4 plus 5 is 9 minus the dimension of their intersection. So dimension of their intersection is equal to 9. Taking this to the other side, 9 minus the dimension of their sum, putting this dimension one by one. Now if this dimension is 5, we get the intersection, dimension of the intersection as 9 minus 5, 4. If the dimension is 6, we get 9 minus 6, 3. If the dimension is 7, so 9 minus 7 is 2. So the dimension of W1 intersection W2, the possible dimensions are 4 or 3 or 2. Right? Okay.